In session 41 here, we're going to address the concept of the slope of a graphed line. You can think of a slope as we do normally in everyday life, uphill, downhill. The steeper the hill is, the more vertically it goes up and down. The gentler a slope is, the less it goes up and down. I should say the less steepness. So the greater the slope, the greater the steepness as far as a slope goes. Now, we can have both positive slopes and negative slopes. And the way we determine that is we take a look at our graph here. Here's our origin in the middle. Here's our x-axis and our y-axis. Now, just as we do when we read, in our country when we read from left to right. Well, in math, in algebra here, for determining slope, you start at the left-hand portion of whatever graph it is that you're looking at, and you move toward the right. Starting left and moving right, once we intersect this red line here, the only way for us to travel the line by still going to the right would be going up the hill. So in this graph here, the red line determines uphill. The blue line determines downhill. So then, a slope that is going uphill has a positive slope to it. So a positive slope for uphill. And then a negative slope for downhill. Now the steepness of the slope, the steeper it is, the bigger the slope will be. The more gentle the slope is, the smaller the number will be. A big negative number for a slope means a very steep downhill slope. A smaller negative number, such as a -1 or a -2 or a -1/2, those smaller negative numbers would indicate a gentler slope. So you can think of the slope steepness as being the rise of it going vertically over a particular distance going horizontally. That is what we determine or define the slope as being. For our lines here, for linear lines, linear equations which have straight lines as a graph, the slope of a particular line is going to be the rise divided by, or the rise over, the run. Now, which of these axes, the y-axis or the x-axis, do you think is going to handle the rise? Well, the y is. The y represents going up, so you're rising up. The run represents how far horizontally you're going. So let's take a quick look here at an example. If we say this point right here on the line, and then we go over here to this point here, between these 2 points, what is the slope? Well, it's important to remember that when you have a line, you can choose any 2 points on the line to determine the slope, because the slope of the entire line remains constant over the entire line. So whether or not we chose these 2 points here and found out the slope, the rise over the run of these 2 points, or whether we chose 2 points down here in the third quadrant, it doesn't really matter, because every point that's on this line, when you choose them as a pair of points, will have the same slope regardless of which points you chose. Okay then, rise over run. Well, let's take this first point. This first point is 1, 1. The x value is 1 and the y value is 1. Over here at our second point, 1, 2, 3, 4 is the x. So I'll go ahead and write that down. And at x equal to 4, y equals 1, 2, 3, 4, 5. So then, our rise is what we look at first. How much did the slope rise? How much, I should say, did our y coordinates between these 2 points rise? Well, how do you determine it? Once again, you start left to right. Which of these 2 points here is furthest to the left? Well, this one is. So we take the y-coordinate of that point. Well, the y-coordinate of that point is 1. And we go to the second point that's on this line that we're using. What is the y-coordinate for that point? Well, the y-coordinate for that point is 5. What is the difference between positive 5 and positive 1? Well, 4 is the difference. 5 minus 1 being 4. The next thing we're going to do now is take our run. We use our same 2 points and we start with the point that's furthest to the left. What is the x value for this point? Well, the x value is 1. What is the x value for the second point? Well, the x value is 4. What is the difference between 4, your second point, and 1, your first point? Well, the difference there is 3. So what is the slope of this line here? The slope is 4/3. Positive 4 over positive 3. That is the slope of this line. The slope of the blue line, however, is going to be negative. But we're not going to determine that exactly now. We've just done the positive. But it's enough to know that this blue line represents a downhill slope, which would then give us a negative slope. Okay, going a little bit further. Here is a smaller condensed version of the graph. Here's your y-axis, here's your x-axis, and this point right here will be our origin. Now, the question is, between these 2 points on this line, what's the slope? Let's rise over run. We start here. Our rise is how far up or down we go on the y-axis. So we're going to look at the rise first. Our y value for the first point is 3. Our y value for the second point is 6. So our rise is going to be the y value of the second point minus the y value of the first point. What is 6 minus 3? Well, it's 3. So our rise is 3. Well, what's our run? Our run is the difference in the x-coordinates between the first point and the second point. Well, the x-coordinate for the first point is 1, and the x-coordinate for the second point is 9. You take that second point and subtract the first from it. 9 minus 1 would be 8. Once again, this is going uphill, uphill being a positive slope, so the slope here of this particular line is 3/8. Lastly here, and then we'll get to our review. Find the slope of a line with the following equation. You have 2x plus 5y equals 10. Well, before we can find this slope, we need to get a couple of points identified that solve this equation. So once again, let's try to find points that are easy, quick. Well, let's choose x as 0, and we'll find out what y equals. When x is 0, 2 times 0 is 0, so that wipes that out. That leaves us with 5y equals 10. Well, 5 times what number is 10? Well, 5 times 2 is 10. So when x is 0, y is 2. That's our first point, at 0, 2. Well, let's see if we can flip things around here. Instead of the x being 0, let's see if we can make the y 0. Stick a y of 0 here. What's 0 times 5? It's 0. 2x plus 0 is 0. So what we're left with then is 2x equals 10. Well, 2 times what number is 10? 2 times 5 is 10. So there's our second point. 1, 2, 3, 4, 5 for x, 0 for y. Then I could go ahead, connect those together, and there's our line. Now, the question is not to graph the line, the question is what's the slope? Well, now with our line graphed here, and we have 2 points on it, it shouldn't be that difficult to find the slope at all. All we have to remember is our slope formula. Slope equals rise over run. Well, taking a look at this one, remember we go from left to right. And as we go from left to right, are we going uphill or are we going downhill? As we go from left to right, we're going downhill. This example up here, we were going uphill from left to right. And this one here, we're going downhill. So once again, it's rise over run. our rise being the up and down on the y-axis. What is our y value, our y coordinate for the first point here? And remember, the first point is the point furthest to the left on the graph. Or our y value here is 2. What is our y value for the second point? Or our y value here is 0. To determine the rise, you take the y value of the second point and you subtract it from the y value of the first point. Well, what is the y value of the second point? Well, it's 0. And we subtract from that 0 the y value of the first point, which is 2. What does 0 minus 2 equal? Well, it equals minus 2. So what is our rise? Our rise is minus 2. Our next part now is to determine our run, and we'll put that in the bottom here in the denominator. Our run is the difference of the x-coordinates between our first point and our second point. Well, what is the x-coordinate of our second point here? Well, it's 5. What is the x-coordinate of our first point? 0. What's the difference between 5 and 0? 5. Positive 5. Remember, you take the x value of the second point and you subtract it from the x value of the first point. 5 minus 0 is 5. So our slope for this second line is a negative 2/5. And once again, the negative slope indicating we are going downhill. Okay, then, quickly as a review, the slope of a line determines how steep the line is. The bigger the number is, the bigger the slope, the bigger the steepness. You determine a slope by going from left to right on a graph, the same way that we do when we read, because we read left to right. An uphill slope is positive, a downhill slope is negative. Horizontal lines have a slope of 0. A horizontal line would be a line that's parallel to the x-axis. And since it's parallel to the x-axis, it never intersects the x-axis. It stays parallel to it the whole time. That would indicate perfectly flat land. Land that has no rise to it, it's completely flat. A horizontal line has a slope of 0. Vertical lines, however, have an undefined slope. And that's similar to the problem we ran into earlier in the sessions with dividing by 0. Just as you can't divide by 0, and as well as you can't have any definition to 0 divided by 0, you run into the same thing here. Vertical lines have an undefined slope. Lastly, your slope formula, your slope equals the rise over the run. That'll finish up session 41.